In this video, we're going to talk about exception handling. And if you don't know, an exception is just another word for an error. And Java, being run in a virtual machine, can catch a lot of its own errors, but when it does, it's going to throw that exception. It's going to show it to you in the console, but it's also going to crash your program in most cases. To avoid that, we're going to look at some different ways you can handle those exceptions using try-catch blocks and prevent your program from crashing. So what I have here is some startup code. I've got a game class with a player in it, and I've got a play game method. And in this method, we're just going to try to heal the player. Nothing complicated. Here's my player class. I've got a few member variables here, and you notice my player starts off at half health. And then we have this heal method. We're going to prompt the user to enter an amount to heal. We're going to take in that input, and we're going to try to heal the player. So that's what we're starting with. And let's try this out. You can see right off the bat, I get this exception, and that's what we're trying to prevent. Here, it's telling me I have a null pointer exception. So let's look at that. You can click on this line here, it'll take you to line 32. When it called this, that's when we got the exception. And the null pointer means that player 1 has not been instantiated yet. There is no object there, so we cannot call methods on it. The proper way to fix this would be to put new player here, and we'll do that shortly. But to show you the mechanics of the try-catch block, what we're going to do is type the word try. Open curly braces, and then close curly braces, and then we write the word catch. Inside the catch, we can put our exception, null pointer exception. Inside the catch block, you can do whatever code you need to do to handle this exception. In some cases, you may just want to print out the error, so we can do a simple error message EX on the end here, and that's going to print out your error message using the toString method defined in null pointer exception. It's not going to be much different than what you see down here, except for that our program is not going to crash. So let's try again. Okay, we get our error message down here. This is what I typed in the text. This is the toString method, and then our program does end because there's nothing else we can do here, but it doesn't crash. If we had other code that followed up after this catch block, then that code would be executed. So there's the general setup. We have a try block with the code that we want to run, and you can put several lines of code in here. And if at any point during this try block a null pointer exception is thrown, it's going to jump to the catch block. We're going to execute the code in there, and then it will carry on. It picks up right after the catch block. Now let's fix our null pointer exception the proper way. New player. And we run our program again. Enter the amount to heal, and I'm going to type yellow. And we get another error because yellow is not an amount. And we can go to my code on line 46. Nope, sorry. We can go to my code on line 15. And it says amount equals scanner.nextInt. That's the code I have there. We're expecting an integer. So when I typed in the word yellow, we got an exception. And this time it's not null pointer, it is input mismatch exception. Looking for an integer, found a string. So there's the mismatch. Now we could wrap this in its own try-catch block to prevent that. Or, since we're calling that method from here, and we already have this in a try-catch block, we can choose to throw exceptions back to where the method was called and let this area handle it instead of handling it directly right here. So if you wanted to do that, when you define your method, you type throws and then give the name of the method you want to throw. In this case, we're wanting to throw input mismatch exception. If we encounter the exception here in the heal method, it's going to throw it back to the play game method, and we'll pick it up here with this try catch block, but I don't have a catch for input mismatch. So can add on to what I already have here and just create a catch block for input mismatch. And here I can put out another error. You must enter a number. So now if someone types anything other than a number, it's going to drop us off here. And then we could rerun this with a loop. Set a loop up here just so it can prompt them again. So this time I enter yellow and my program does not crash. It throws the error back down to play game. We catch it here, we see this message, and the loop goes and it's asking again. Now I will try an integer, let's say 10. Player healed to 60 points. I'll do 10 again, 70 points. It works just fine. Now what if we want to catch any exception and we don't want to be specific? We can do that as well because every exception is derived from throwable, and from throwable comes the general exception. So you can stack these catch blocks as much as you need to. It's going to look here first. It reads them in order, and if it hits this, it will handle it with that. And if one of these works, it will use it. But if none of these work, it will fall on this last one and say it's just a general exception. It will tell you what it is, and at least your program will not crash. Now, so far we're only working with exceptions that are built into Java, built into the virtual machine. But what if you want to put in your own exception? You can do that. So let's create a class. Everything in Java comes from classes. Everything's an object, including exceptions. So here we'll put negative number exception. What if the user enters a negative number for the heal and we don't want to allow that? Now we have an exception class that we can use to throw an exception and let them know that is not allowed. Extends exception. Inside this class, you can do whatever you want. It's just a class. We can have a constructor and have this print a message. You must enter a positive integer. You could come down here and override your toString method if you wanted to do that. But you can put whatever you want in here. So now, how do we use this class? We've got our logic for handling the user's input right here. But I can put another if statement that says, if amount is less than 0, throw. Up above we are using throws to throw it back down here, but we can also use throw to force an error to be thrown. So throw new negative number exception. And I get an error and it says unreported exception. Negative number exception must be caught or declared to be thrown. So we either have to write a try catch here or we have to throw it back down here where we can handle any exception, and that's what I'm going to do. So up here I put throws input mismatch. I can also put my own custom class negative number. Tag it on there with a comma, and let's see if it works. Okay, this time we type yellow. You must enter a number, enter amount to heal. This time I type negative 12. You must enter a positive integer, general exception. And then we get our exception handling. We did not override the toString, so it just prints out whatever it can from the object class, and then we loop. So we see we get the message from our constructor. You must enter a positive integer, and we get this message here because it was handled by this catch block. And that is the basics of exception handling in Java. That covers how normally you're just going to use a try catch where you need it and print out your error. Or let's say you had a database connection and your connection failed. Maybe in the catch block, you want to try to reestablish that connection. So there's other things you can do in the catch block, but I guess in the most simple case, you're just going to print out that error and still prevent your program from crashing.